We're going to do now one example of a halogenation reaction of an alkene. So here I am drawing methyl cyclohexane. And as we have seen in other videos, this carbon is less substituted, this is more substituted. Always need to remember that when we're doing reactions that are region selective. In this case, let's do the halogenation. Halogenation is when you're using a halide, and typically in an organic solvent that is not nucleophilic. We can do, for example, carbon tetrachloride. So what happens here, and the halide could be chlorine or bromine. This reaction proceeds through an intermediate chloronium or bromonium. So let's say that we do this bromine. Here you will have pi electrons acting as nucleophile, but what you're forming is a bromonium intermediate. Let me draw this better. Let's have more room. Well, when we do this bromonium in this departing, we're going to make the following intermediate. Say that this approaches on the top side. The intermediate is called bromonium, and you will have here, you have a metal group. So if this is forming on the top, and this is positive here. So the metal will be on the wedge. Of course, you have bromide after you do that. So this intermediate, again, if this is a plane where the molecule is, this is on top, so like that. Now, the nucleophilic attack happens opposite, so similar to what you have seen in SN2 reactions. So this will be acting as your leaving group, so the attack is on the back side. And so what you will see then is the attack, let's do that in a different color now. Now we have electrons, remember. I always like to draw my electrons. So you will have the nucleophilic attack, and this will open up. So nucleophilic attack and leaving group. And what we have here is the following. So notice that we have attack opposite to the leaving group. And that way, that what it says is the attack happens so opposite side. So if here I have the metal, I will have a bromine, and I will have attack with the bromine on this side. Notice that the two bromines are added opposite side. That's what's important about this reaction, that they happen through this intermediate that is cyclic, and you will see several intermediates like that. We, in the halogenation with oxymercuration, we do have that, and also in epoxidation. Now, when we use other reagents, so per acids. Anyhow, in this reaction, you always insert a halide, and you will do that in that fashion. You create that, again, on top of the plane of the molecule or below. And then you have the nucleophilic attack opposite to the leaving group, similar to your SN2 reactions, where all of that is your leaving group. All of these, that's your leaving group, and that's your nucleophile. So attacking opposite side. Of course, if you did this on top, you could also do it on the bottom, and that creates another possible product. So if this was on dashes, let's do, let me do the other bromonium to make probably is better. The other bromonium that you would form is, say that I added that like this. And now the metal is here. Oh, I don't like those arrows. Okay, better. Now, what I'm saying is that I formed that bromonium here, and this is the other drawing on the bottom. And again, the attack needs to be opposite sides. So if this is under, the attack is this side. The attack by what? By bromide, which is my nucleophile. So if you're doing this, say that you're attacking, you will make another product. That product is the following. You have now bromine, and here you will have opposite side. If this wasn't Dutch, this is English. Notice that this chiral center here is inverted. The center is inverted, so you are producing a pair of enantiomers. So these two are enantiomers. And pretty much this is a 50-50 ratio. So the product is racemic. So if you're being asked about if the product is optically active, this is not, because it is a racemic admixture.